In this lecture about materials, I will focus on the production of components. You will see that there is a big interaction between material properties on one hand and the production options on the other hand. The performance of a product depends highly on its design, the selected production method, and the material used. There are interrelationships between these three entities. Just as an example, in the background of this slide you see the Eiffel Tower in Paris. If I ask you what is the type of structure of the Eiffel Tower, what material is used, and how is it produced, what would be your answers? The structure is a truss structure. The used material is an iron derivative, and the struts are made by a forming process. You can also ask, could such a structure or shape also be made of another material, for example wood or concrete? You would probably sense that this would be inappropriate. If you change the material, you also need to change the shape and the way you manufacture the shape. That's why I think you should use a triangle, as in this slide, and realize that some combinations are possible, but others are not. I can underline that even more by this slide. If you need to develop a concept for a product or a structure, you need to choose a shape, a material, and a feasible production method. When choosing, for example, a three-dimensional thin-walled shape, ceramics as material option would not be possible. Metal alloys and composites might be feasible. A metal shape could be made by using a sheet forming process. A composite shape could be made by using layup techniques. Casting or forging would not be possible, neither for metals nor for composites. A nice homework assignment would be, what are the impossible combinations in this slide? The applicable production methods are related to the material. First, let's look at the metal alloy. Most metals can be casted. The metal is heated above its melting temperature, so the metal becomes liquid, and the liquid metal can be poured into a mold. After cooling down and removing the mold, we obtain our part. See the picture on the left. Another way of manufacturing a metal component is by machining or cutting. A hard and sharp chisel cuts away small bits of material, named chips, until the final shape remains. A third method is forming. In this case, a rolling process is shown. In forming, the plastic behavior of a metal is activated. The forces on the material become that high that permanent or plastic deformations occur. Note that melting and plastic deformations are characteristic for metal alloys. For composites, we use other manufacturing methods. I will go through two of them. First, the common process of layup and curing. In a mold, which has a shape of the part, we place layer after layer on the right location. Once the layup is complete, the stack of layers is packed in a vacuum bag and cured in an autoclave. The vacuum bag removes air to prevent voids in our product. The autoclave cures the composite at high temperature and high pressure. After a few hours, our product is cured and further processes can be applied. Another process is filament winding. Filaments of fiber bundles are wound around a mandrel or a mold. Before the fibers are positioned on the mandrel, the fibers are impregnated by resin. Therefore, the fibers are guided through a resin bath. Once all fibers are impregnated and positioned onto the mandrel, the resin needs to be cured. This will be done in an oven, so at high temperature but ambient pressure. The two previous slides show the differences in the manufacturing of products, which are made of different materials. Some of the material properties we have seen before influence the choice of the most appropriate manufacturing process. If we look at metals, they can be melted, they show plastic behavior, are cheap, can be easily processed, for example by machining, and they can also be joined easily by rivets or bolts. For composites, we see that the fibers and resins need to be impregnated or mixed, that uncured materials are very malleable, and that continuous fibers are often used to steer the process. Another typical difference is that metal structures often are assembled from many components, whereas composite structures have a high degree of integration. And realize assembly can be very labor-intensive, but on the other hand, composite materials can be rather expensive themselves. Just to illustrate the different ways of manufacturing, on the left-hand side you see a metal structure made of many components, riveted together. Most parts are made of metal sheets, which are formed into stringers, frames, etc. In case of strong and heavy frames or parts, forgings or castings can be applied. The composite structure on the right-hand side is a much more integrated structure. Local thickness variations are made in one autoclave cycle. The reinforcing stiffeners are bonded in a second cure cycle. These stiffening skins can be made by laminating, or the skins can be made by filament winding. Besides a difference in manufacturing processes, different materials also result in different designs. The stiffened shell structure in the left picture is typical for metal structures. The sandwich structure in the right picture is typical for composites. This underlines once more the triangle of design, manufacturing process and material, which is very important. So to conclude, materials, design and production are highly interrelated. This becomes very obvious if one compares the shapes and manufacturing processes of metal alloys and composites. The manufacturing processes are based on particular material properties. Also, the designs or shapes depend on the capabilities of the production processes.